Humanity has done big efforts along history to explore and discover new horizons. For example, we have reached the space and mapped completely the Moon, so Earth shouldn't have any mystery for us. Or yes? Well, 71% of Earth is covered by oceans and we could only map about 20% of the ocean seabed. But why? Why haven't we mapped all ocean seabed yet? Traditionally, it requires sailing the seas with onboard sensors in boats or underwater vehicles. These techniques can be very expensive in terms of time and money. Therefore, mapping the seas is still a pending task for humanity. Satellites can be used to directly map the land surface, but mapping the seas is another story. Almost no light can penetrate more than 100 meters and come back, so it's impossible to use satellite to study the seabed in deep waters. However, recent studies confirm that with some limitations they can be used to map the seabed in shallow waters. The satellite techniques to measure the depth are still very experimental, but they can be a big step forward to the scientific community to quickly map all coastal areas. Thanks to OGS, the supercomputer cluster of Chineka, and Praise, this summer we have studied two experimental techniques to measure the depth on the Calabrian coast in the south of Italy. When a beam of white light penetrates the sea, the different wavelengths are attenuated in different proportions. As we see, blue is less absorbed, so it can penetrate deeper than red, for example. We worked in shallow waters with depths from 0 to 20 meters. At those depths, visible colors are not absorbed completely, and if we compare reflectance ratios between blue and red or blue and green, we will see that the deeper, the bigger these ratios are. We worked with this technique on the Calabrian Sea in the south of Italy using a multitemporal set of satellite images from Sentinel-2. We could do a map of this area with a mean absolute error of 3 meters. But we didn't stop here, and we went further. We used this magic black box called machine learning to get better results and study other possible estimators to measure the sea depth. In total, we studied up to 20 different estimators. So we did our magic and we got better results with a mean absolute error of about 2.3 meters. Here, I extracted the absolute error of each pixel of the map using the last algorithm and the machine learning algorithm. We observed directly that machine learning gives better results. The chosen machine learning method was random forest because it can compute the importance of each variable. We worked with a total of 20 variables, 8 color bands, and 12 ratios between the blue bands and the rest of the bands. 8 color bands and 12 ratios between blue bands and the rest of the bands. We made bar graphs of the importance, getting interesting results. The most important colors are blue, red, and near infrared. Regarding the ratios, the most important are the ratios between blue and red, blue and green, or blue and near infrared. The rest of the estimators can be omitted without deteriorating the result. Using the last algorithm, we had considered blue, red, and green, but not infrared. However, we found out that this feature can be as important as the others. It seems that near infrared just penetrates a few millimeters into the water, so it doesn't work for estimating depth. However, when we work with machine learning, it gives us a noise correction of the water surface, and that's nice, because it proves that if we want to study a new problem, machine learning can give us information of what variables are more useful to solve the problem. To sum up, we have proven that satellite imaginary can be used to estimate the depth in shallow waters. Then we tested two algorithms, a band ratio algorithm and a random forest regressor. We found out that the random forest works better than the ratio algorithm. Moreover, it can give us information like the importance of the estimators.